If I ever win the real life lottery, I'm going to start playing the silicon lottery. So I'll take my $1 million and buy 3, maybe 4 if prices come down and I can afford it, of the same video card. Because we all know that video cards from one model to another, there will be some degree of variance in what would be a stable overclock. They don't all overclock the same. And the same is also true for applications. For instance, you can get an overclock in one game that's not stable in another. And so today we're going to take a look at just a gaming benchmark, but really focus on some professional benchmarks, such as mining and folding at home and Adobe Premiere, and see what's stable in these applications. Which one has the best overclocking headroom? I don't know yet. I haven't started testing yet. But luckily for you, because this video is edited, you'll get to see those results in a few seconds, whereas I have to wait a few hours after a bunch of benchmarking to see these results. As for GPU settings for all these tests, I cranked up the power limit to 120% and the temperature limit up to about 92 Celsius. Starting off with some overclocking settings I guessed would be safe: 120 offset on the core and 240 offset on the memory. Things were just peachy keen. Bumped it up to 125 on the core, 300 on memory. This brought us up to 1987 MHz core and 4303 on the memory. Again, things were nice and workable. I won't bore you with all the intermediate steps over the next 10 times I ran the benchmark, but eventually I cranked everything up to 215 offset on the core, 315 offset on the memory, bringing us up to 2088 core and 4320 on the memory. At this overclock, the app crashed, meaning the program just disappeared and I went back to my Windows desktop. Taking 5 MHz off the core or the memory didn't stabilize it until I took 5 MHz off of both, and then things settled in at 2075 core, 4314 memory. Next up is protein folding, using folding at home. I had to use the benchmark for this because different work units that you get in the real world will vary in terms of overclocking stability, so to keep things consistent, we're just using the benchmark here. Something interesting to note here is that whenever you're running certain compute-based applications, it automatically underclocks your memory by a couple hundred megahertz. So what ended up being stable here was 220 on the core, bringing that core clock speed up to 2113. And as for the memory, even though the offset was 550, it wasn't that much faster than the 310 we got last time, because the actual result speed of memory was 4353. If I crank things up to 225 on the core or 555 on the memory, the test doesn't necessarily shut down the program like it did for Unigine Valley, but rather it says test failed because particle coordinate is not a number. So already here we're basically seeing another 40 megahertz of core clock speed that we can get for folding at home that we could not get in our gaming benchmark, and another 40 megahertz on the memory as well. Next up is FluidMark. Not really a professional type application, but if there was some professional application out there that used physics-based processing to simulate particles, then who knows, maybe this could be useful. As for the FluidMark settings itself, 1080p windowed, more graphics, post effects, multi-thread async, which means that I can run the physics simulations and the frames per second independently of each other, meaning if I'm only able to simulate 60 calculations a second, my frame rate is not limited to that 60 FPS limit. So the first overclocking settings I tried failed instantly. The whole system just completely locked up. Couldn't open Task Manager, power button did nothing, completely frozen. So then I dialed back to default settings and eventually worked my way all the way up to 190 offset on the core, getting us up to 2062, and 280 offset on the memory, bringing us up to 4284. One reason that this could be less stable in overclocking compared to Unigine Valley is that when we were running Unigine Valley, the core was 61 degrees Celsius, and in FluidMark, our core was at 66 Celsius. So who knows, maybe that 5 degrees is what's really making the difference in stability, or it could be the workload itself. And speaking of workloads, Adobe Premiere. Now this one, I was really surprised at just how far I could push it. In fact, I ended up using 3 sheets of paper just to keep track of which overclocking settings I applied and if they were stable or not. I ended up crashing when I tried an offset of 270 on the core and 700 on the memory. I knew it wasn't working when the actual resulting core clock speed went down to 1607 and the thumbnail displaying the progress completely froze. Our core temperature was only 59 degrees Celsius, too cooler than when we did Unigine Valley, but we were still able to eventually work in an offset of 260 on the core, bringing us up to 2126 on the actual core clock speed, and an offset of 660 on the memory, getting us up to 4463 in actual memory clock speed. For the last benchmark we have, Ethereum mining. So the core on here started at 62 Celsius, but hours later with continued benchmarking it worked its way up to 64. With the first set of overclocking settings I applied, 100 on the core, 250 on the memory, bringing us 1961 on the core and 4050 in real-world memory clock speed, we were getting 28.46 megahashes a second, or as NiceHash called it, $1 a day. Eventually, we did work our way up to 32.45 megahashes, or $1.12 a day, because we had a core offset of 200 and a memory offset of 750, making our actual resulting core clock speed being 2037, more on that in a second, and our actual memory clock speed was 4551. We gained an entire gigabit per second plus on the memory thanks to overclocking. Okay, so about that core clock speed. Once I got to an offset of 150 on the core, that brought us up to 2012. I went for a core offset of 165, and that bumped us up to 2037. And then with each subsequent core offset from 175, 180, 185, 190, 195, and 200, the core just would not go over 2037 megahertz. I did push the memory all the way up to 777 offset, bringing things up to 4579, and that's when I got a bunch of artifacting. And even when I reset all the clock speeds to default and closed the mining application, nothing got rid of these artifacts, so I had to reboot to get that cleared. Going into this testing, I pretty much guessed that Premiere was going to be the most stable, because a lot of these other applications, particularly FluidMark, Folding at Home, and Unigine Valley, those are all stressing a lot of the 3D parts of the GPU, whereas Adobe Premiere, with the effects that I use in my projects, I'm not really calculating anything three-dimensional. So there's parts of the GPU core itself that just aren't being used, and if those are some of the more unstable parts, that would allow me to clock higher. The thing that did surprise me the most, however, was just how stinking far I could push that memory when it came to Ethereum mining. I would never have guessed that I would be able to push things more than 10% on the memory. I would have run more games in here just to kind of demonstrate how game-to-game overclocking can even be something to worry about. But when I went to fire up Metro Last Light with a set of overclocks pre-dialed in before I even tested the game once, this happened. And even if I reset all the settings to default, it would still do that, which meant that something was messed up either in the drivers or the game files. So I'm going to be taking a look at what's going on with that, and if I find out, I'll be sure to make another video. Alright, now that we've been able to look over all the data together, concluding thoughts. I was actually pretty surprised at how much difference there was when it came to memory clock stability, to the tune of a couple hundred megahertz. But when it came to core clock, I was surprised that it was really only about 50 megahertz. I thought it was going to be something a lot higher, to where I'd basically not even be able to get away with Ethereum mining and boosting the core clock at all. So I thought that was pretty interesting. If you found something else that's pretty interesting, make sure to leave that comment down below, as well as give this video a like, subscribe to this channel, and check out some of these other videos about graphics cards, overclocking, and other video card stuff, because I make video card videos and some other stuff, but I really like video cards, as you can tell.